Section 1.5 Differential Techniques. Basically, we're going to learn techniques about finding derivatives using shortcuts. What we did in the previous sections, we used the main definition of derivatives, but that one took some time actually to find. When we did the limit as h goes to 0 of f of x plus h minus f of x over h, that took a lot of time. So what we can do here is we can go ahead and learn new formulas. So first, to find the derivative of function f of x, we can use the symbol f prime or y prime or dy dx. All of them, they mean the same thing. They represent the derivative of a function f. F prime, y prime, or dy dx. dy dx means the derivative of y with respect to the variable x. So the first rule and the most important rule is called the power rule, which says if you have a function written in the form x to some number m, its derivative is given by bringing the m down to the front, or multiply the m by whatever is in the front, x to the m minus 1. X to the m minus 1. That's called the power rule. So you bring the m down or multiply m by whatever in the front, x to the m minus 1. For the next one, for the first example, is we keep the 3 halves as is. We bring the 2 down, x 2 minus 1. These cancel, so that gives us 3x to the first power, or simply 3x. Next example, y equals simply x to the 7. That would be 7x to the 7 minus 1, 6. Recall some properties of exponents that we use them a lot here in calculus. The first one is the nth root of x to the n. You can write as x to the n over m, the inside over outside. Anything to the 0 power is 1. X to the negative m is 1 over x to the m. If you multiply both with the same base, you can add the exponents. If you divide them, you can subtract the exponents. These are exponents of properties of exponents that we need from algebra to help us in solving calculus problems. Next one, they ask us find dy dx for this function. Dy dx means find the derivative the same way. So how do we do this? We bring the negative 6 down, x, and subtract 1 from that. That gives us negative 6x to the negative 7. Then you bring that down. So it's negative 6 over x to the 7. We can't have negative exponents. Since it's negative here, I use this property and I brought it down. But you keep the negative 6 there. It's okay to have negative 6, but we can't have negative exponents. Then if we are given another example, 1 over x to the m, or x to the 8. There's no formula for that, but what we have to do is to rewrite it to make it look like x to the m power. So that would be x to the negative 8. 10, then we get negative 8 down, x to the negative 8 minus 1, it's negative 9. But again, it's not done because the negative sign, you need to bring it down as x to the 9th power, x to the 9th power. Then another example, more tricky, 1 over the cubic root of x squared. Again, we need to do some rewriting first before we actually start finding the derivative. And how do we rewrite this? The denominator part you can write as x to the 2/3, based on the property of exponent that I showed earlier. 2/3, and then you bring it up, x to the negative 2/3. It's ready. Now it looks like, this looks like x to the m. You bring the m down, subtract 1 from the exponent. And how do you subtract the 1? On the right side, I showed how you combine the two fractions to get negative 5/3. But it's not done because there's a negative exponent here. So this negative exponent needs to be cleaned up by bringing that down. So that would be the answer for this one. Now what about if we have more than one function? So f of x plus g of x. The way you do it, you find the derivative of f plus the derivative of g. If it's minus, the same way. So if I'm asked to find the derivative of x cubed plus x squared, to do that, we just simply find the derivative of each one of them and add them up. So the derivative of x cubed is 3x squared, and derivative of x squared is 2x. As I said earlier, for the subtraction, the same way, it's f prime of x minus g prime of x. So if I want to find the derivative of x to the 6 minus x squared, that's 6x to the 5th minus 2x. The derivative of any constant, any number, is always 0 if the number is just by itself. For example, if we are asked to find the derivative of all this expression, we take it one at a time. The derivative of this one, you bring the 4 down. 4 times 3 is 12, and subtract 1 from the exponent becomes 3. This one, you bring the 2 down, subtract 1 from 2 becomes 1. X to the first power, you bring the 1 down, subtract 1 from 1 is 0. And that's a constant, so its derivative is 0. And to rewrite it in simplified form, this is 12x cubed minus 2x plus 1, because anything to the 0 power is 1. Another example, how about if we're asked to find the derivative of something like this? You're welcome to pause the videos first and try it before you actually see how I'm doing it, or I'm gonna do it. So this is square here. So how do you find the derivative of this? You simply find the derivative for each one of them. The first one is a number, 8.16. That's a constant. So its derivative is 0. By the way, this is saying, this symbol here saying find the derivative of all of this with respect to the variable x. Here, find the derivative of all of this with respect to the variable t. So the derivative of 8.16 is a constant, 0. Derivative of this one here is 2.3. Derivative of that, 2.3. Always, derivative of ax, a is a constant, is simply a. Derivative of like 2x is 2. Derivative of 5x or negative 5x, it's negative 5. So here it's simply 2.3. For the next one, we multiply the 2 by this, that becomes 0.04, and subtract 1. So the answer would be 2.3 minus 0.04t. That's what this section is about, is using the power rule. And it's a shortcut. You don't have to do limit anymore of f of x plus h minus f of x over h, starting with this section. So we will learn more tricks and techniques about finding derivatives of functions in the later sections.